So, in our last video, we talked about how the decimal number system is an extension of our whole number system. Because if you're looking at the whole numbers and you take any place value and multiply it by 10 or make 10 copies of it, then you're going to get the next place value to the left. And if you reverse that pattern and divide any place value by 10, then you get the place value on the right. And so if you take a whole unit in the ones column and you divide that into 10 pieces, that creates the first decimal place value of 1/10. Because if you take a whole and cut it into 10 pieces, you get a fraction of a whole. And if you split that into 10 pieces, you get a hundredth. And if you split that into 10 pieces, you get a thousandth, and so on and so forth. So, the way that you write a number in scientific notation is you take the digit that's in the largest place value. So, in this first number, that would be the number 5. And that number is going to be written to the left of the decimal point. And then the rest of the digits will be written after the decimal point. And if you have a really, really large number with a whole bunch of zeros, you don't have to write those zeros in the decimal because 5.41 is the same decimal as 5.4100000000. And so we can just write it as 5.41. And then we're going to multiply this decimal by 10 to an exponent, where the exponent is determined by how many times we would have to multiply this decimal by 10 to get the number that we were given. So remember that whenever you multiply by 10, all of the place values shift one place value to the left. And so if the decimal point in our decimal is between the 5 and the 4, if we were to multiply by 10 once, the decimal would move to here. If we were to multiply by 10 again, that would move it to here. And so we look at how many times do we need to multiply by 10 to get the decimal point to where it is in the number that they gave us. And in this case, it would be 10 times. And so we would write this as 5.41 times 10 to the 10th. Now, if you're trying to write a really small number in scientific notation, the process is similar, except instead of multiplying by 10 a certain number of times, you're going to divide by 10 a certain number of times. So this blue number, if we were to write it in scientific notation, would be 2.3 times 10 to a negative exponent, because a negative exponent signifies that you're going to be dividing by this number repeatedly instead of multiplying by it. That's what a negative decimal or a negative exponent means. And so if we look at this and we say, okay, well, if we have the number 2.3, the number of times we would need to divide by 10 to shift the place values to the right would be 1, 2, 3, 4, 5, 6 times. And so that's what determines our exponent. So we'll have 2.3 times 10 to the negative 6. And what that means is that if you take the decimal 2.3 and you divide by 10 6 times, that's going to be equivalent to the decimal that they gave us. And so when we're comparing numbers in scientific notation, we need to remember that the exponents of the powers of 10 are telling us how many times we're multiplying or dividing by 10, which ultimately is telling us what place value these numbers are in. And so when we look at this, it looks like we have four of the numbers that are positive exponents and two of the numbers that are negative exponents. So these two negative exponents tell us that we're dividing by 10, which means that the 9 and the 2 are going to be in decimal place values. And so the 9.99 times 10 to the negative 3 is going to be the smallest number because the 9 is in a very, very small decimal place value. And then the next smallest number will be 2.67521 times 10 to the negative 2. That will be the next smallest one because that's the only other number that has a decimal place value as its largest place value, because all the rest of them have positive exponents, which means you're multiplying by 10 rather than dividing by 10. And so now that we have those listed in order from least to greatest, The next smallest place value is going to be the green one, because this one is multiplying by 10 4 times, while the purple one is multiplying 5 times, the red one's multiplying 5 times, and the yellow one is multiplying by 10 8 times. And so the green one will be our next smallest one. So we have 7.1 times 10 to the fourth. And then the red one and the purple one are both multiplying by 10 5 times. So the 3 and the 8 are both in the same place value. But because 3 is smaller than 8, that's going to be the smaller number. So we'll write that one next as we're ordering these from least to greatest. And then we'll have 8.14 times 10 to the fifth as our next one. And then the yellow one is the largest number in scientific notation because this one is going to be in the largest place value because you're multiplying it by 10 8 times. And so that's how you can compare numbers in scientific notation. The key is to look at the exponents to see what place value all of these whole numbers will be in. So if you have any questions, let me know, and I hope that you guys have a great